Today on the Perception and Action podcast, my interview with Bill Warren from Brown University, discussing his extensive body of research using an ecological approach to understand perception action. So it's time for a call to action. Hello, and thanks for joining me. This is Rob Gray from Arizona State University. I've been on a now over 25-year journey as a researcher, professor, and high-performance consultant to understand how we acquire and adapt our perceptual motor skills. Welcome to the Perception and Action podcast, where I discuss how psychological research can be applied to improving performance, accelerating skill acquisition, and designing technologies. If you're a coach or an instructor, my goal is to help you bridge the gap between research and application, and to connect your experiential knowledge with skill acquisition and motor learning theory. I want to help take you from using practice design recipes to becoming a master chef who can manipulate the key ingredients to come up with your own innovative training methods. If you're a student or fellow academic working in the skill acquisition field, I hope to keep you up to date on the latest studies and help you get to know the people working in this area. Finally, if you're developing training technologies, I hope to help you incorporate good motor learning principles in your design, pull out key performance metrics from the data, and design effective studies to evaluate your product. To learn more, help support the podcast, and or work directly with me, please check out perceptionaction.com. Now on to the show. In today's episode, I was really happy to be able to talk with a person that has had a huge influence on my research career, Bill Warren. Bill has done some brilliant work on a wide range of topics from affordances in stair climbing, to control of locomotion using optic flow, to route navigation using online control, to studying the behavior of people moving in crowds. I've also really admired Bill's efforts to try and make the concepts of ecological psychology and dynamical systems more understandable. In the interview, we also covered general issues related to the ecological approach, including how are affordances actually used, how do we calibrate to our own action capabilities, and whether or not we can integrate different approaches to perception action. So today my guest is Bill Warren from Brown University. Thanks for taking some time to talk with me, Bill.
Happy to be here, Rob.
So can we start off by, I wanted to ask you a bit about your background. In particular, I think everyone likes to know how you kind of came to the ecological approach, ecological psychology in your career.
Well, I kind of started life as a Piagetian in college. I kind of discovered Piaget as, oh my God, people are studying the mind in the same way you could study biology or physics. And then I went and did a semester abroad at the University of Minnesota, where I heard both James Gibson and Mike Turvey give talks.
Wow.
And so I came out of Gibson's. Gibson gave a talk on why perceiving events does not involve memory. And I remember riding my bicycle home from that talk thinking, this is ridiculous. He's just full of it. And by the time I got home, I said, okay, I'm going to do my senior thesis on this problem. And then I heard Turvey give a talk at Minnesota on his How Does Light Get Into a Muscle talk. And I said, okay, this is what I want to do for my graduate work. And Bob Shaw had previously been at Minnesota and had moved to Connecticut. And I connected up with Shaw. That kind of launched me on that path.
Right. So you had some of the big influences. You've passed it along definitely as well. So what was that first project that you did?
It was a project on object identity in events. So it's like, how do you see that there is the same object undergoing a transformation as opposed to some different object?
Okay. And
so it actually used apparent motion displays using a tachistoscope at the time. And it ended up getting published in Perception Psychophysics. So that was my first publication was
cool.
That honors thesis.
And I know the one of the early things I associate with your work is the affordances, the affordance work. In particular, I always think of the stair climbing work. So can you tell us a little bit about how you kind of came about that topic and thinking about that?
Yeah. So I went to graduate school at the University of Connecticut in the early 70s, late 70s, early 80s. And, there was an amazing stew of ideas at UConn at the time. Scott Kelso was there visiting Haskins. Mike Wade came and visited for a year. Peter Kugler was there as a graduate student ahead of me. And of course, Turvey and Shaw. And so and David Lee came to visit. So there's this sort of stew of ideas. And so we just managed to kind of put things together. And I feel my dissertation work on the affordances of stairs was kind of a synthesis of what I'd been learning about Gibson, and the dynamics that was coming from, the motor control and action work that Turvey was doing, and the information and control from Shaw, and all of that kind of fit together in a particular. I was looking for a problem, and I remember walking down the stairwell from my office one day and saying, "Oh, this really requires a particular fit between the animal and the environment," right? So we've sculpted stairways, we've sculpted our environment to fit our bodies in a particular way. And that animal environment relationship really determines what actions I can perform and how efficiently I can perform them. Mm-hmm. And so I think one of the moves that I was happy with in that dissertation was not only to talk about affordances as, actions we can and can't do, kind of categorical things, but also as having a dynamics to them, right? That there are things that are better and worse affordances. There are things that afford actions that are more efficient or more adapted than others.
Yeah, no, I really like that. Yeah, and there's a couple of things, Bill, I've really admired about your work. Not to put down other people working in the area, but I've admired, one, your effort to make the topic understandable. Some people in this field keep it very high level, and the dynamical system is very impenetrable. And then also the penchant to want to work on kind of real life problems, right? Instead of, the coordination work and things are important, but, it seems like you've always gone more to stair climbing, locomotion, ball catching, now crowds and things. So I really like that. But yeah, so the affordance
Thank you.
You're welcome. You're welcome. It really helped me actually. You reading your work, and I think if I had to start some other place, it would have been tougher. But so in the affordance work with stairs, you were basically having people judge whether they could climb stairs and relating it to their body scaling. One question I always get is, without memory, how do we get to that capacity, knowing our action capacities?
Yeah, so I think of this as really a problem of what Gibson would call attunement, mm-hmm. Or calibration of a perceptual system to the environment. And, so we think about perceiving the environment. The move that Gibson made with affordances is we're perceiving relationships between ourselves and the environment. And those relationships involve not only our body dimensions, right, like objects I can step onto or objects that are within reach, but also the kind of action, the potential for action, right, the mm-hmm. dynamics of action, so my action capabilities. So how do I see, right, in my environment, the relationship to my action capabilities? Mm-hmm. It's easier to, I got there by looking at body scaled relationships, so scaling to body dimensions, right? So for that stair climbing work, it was the relationship between the height of the stair and the length of my leg, and there's information for that relationship in the height of my eye, which is immediately available to us in the optic information, right? Mm-hmm. So I can see the relationship, kind of eye height scaled relationships of the sizes and dimensions of things in the world. So how do you make that leap to body scale, from body scaling to action scaling? And I think it's very similarly, it's a matter of calibration. So Gibson argued that affordances are learned. And so as I walk around the world, I'm learning things that I can step up on and things that I can't step up on, or gaps I can fit through and gaps that I can't fit through. And there's information in the relationship between the sizes of the heights of stairs and the sizes of gaps to my own body size. So I'm essentially calibrating those optical variables for a particular body size, mm-hmm. right? And that's just a constant, right? So it's like, there's some relationship, the height of a stair relative to my eye height, it's 0.26. If there's a stair that's above 0.26, then I can't step on it. If it's below 0.26, then I can step on it. Mm-hmm. So I've just calibrated that. It's just a constant, right? Mm-hmm. But the same thing is going to be true for action scaling of things, right? So there are gaps that I can jump over by virtue of my energy potentials and my strength that can be calibrated in much the same way. And once you kind of calibrate some of those relationships, they generalize to other relationships. So, the gaps I can fit through, the things I can jump over will generalize to streams, to gaps, to puddles, to, all these different kinds of contexts.
Yeah. So this calibration process, I guess critically depends on you being able to interact and kind of explore the environment. I think that's why I always say people, you can lose it so easily. In my sport, baseball, Peter's always talk about losing timing. I think it's calibration, right? You go. It's not something you're gonna have forever because everything's always changing. You need to reestablish it. Yeah. And the affordance, I know. So a lot of, I think people like the idea of affordance, but what are they for? Kind of is another question I get. And I know you put forth kind of the action selection, is that kind of still the way that you think about affordances?
Yeah, I think that's the kind of the first cut, right? So I look around in my environment, maybe I'm, on the playing field and I'm looking at the changing context around me, where the ball is, the gaps that are changing between the players and so on. And so I see the possibilities for action that are changing dynamically all the time as I move through my environment. So that's the kind of action selection problem. But then, okay, so now I'm going to try to make it through that gap. I still have to adapt my behavior to that gap, right? And so that I think of as the control problem. But affordances, it's more than just action selection. It's also it's more than just categorical what I can do and what I can't do. There are better and worse opportunities for action. Right? And so I think one of the outstanding questions still is, how do we understand better and worse possibilities for action? I tried to think of them in terms of energy expenditure, but that's only one variable, right? So there are more efficient and less efficient ways to perform an action. But under other constraints, it might be, I might not be so worried about conserving energy. Time might be of the essence. So I'm willing to, sacrifice energy, to expend energy in order to do something quickly. So there's a kind of objective function that we are still trying to characterize that may actually be not fixed, but may be dynamically depending on the constraints.
Yeah, and I like that description. One of the things I think it's challenging is, I think, in the way, because affordances and control are both using the same information, right? I think there's this tendency, if you put them in the selection, that you're getting this kind of discrete, linear, like we select an action, then we control it based on what we selected, which I don't think it's that clean of a cut, right? So yeah, I think that's an interesting way to think of it. The other, kind of moving forward, the other work I know, when I first met you, I remember seeing you present using Star Wars, videos from Star Wars to illustrate optic flow, flying through trees, right? So Star Wars, you kind of, with that optic flow, you kind of moved to more of the control issue, right? Beyond the affordances. Can you tell us a little bit how you got into that?
Yeah, so I had this subjective experience. It's kind of like what they did in the Star Wars movie of, as I'm walking through the world, right, I suddenly was attending to the fact that everything is flowing around me. And I know a lot of athletes have that experience as well. It's like, I'm moving through the world is moving around me. There's a kind of groove you get into with that, right? And there's this sort of motion, so there's this optic flow around you that's happening and unfolding all the time, and we're normally not very aware of it. But there's a huge amount of information in that pattern of optic flow that we're using constantly, right, to control various kinds of behavior. And so it was that sort of subjective experience of the world flowing around me that said, oh, this is really captivating, and to really start focusing on that problem.
Yeah, and I know one of the I think, to me, one of the big innovations you made in that was really being able to couple it properly, right? When you were able to get the treadmill driving the flow, right? I think that was a really something that a lot of people weren't doing. So you were, a lot of that was initially you were testing kind of one of Gibson's most basic their focus of expansion and heading, and kind of see if you could predict. Yeah.
So I'll make a kind of meta-theoretical comment. I think one of the legacies and maybe burdens that we have in ecological psychology is that there's a lot of high theory that we need to cash out in terms of experimental evidence, right? And so there's a lot of wonderful theoretical discussion, right, about all of these ideas. But unless we have experimental evidence that people actually use this information, right, or organize their actions in a particular way, we don't have a science. And so that's really, I would say my focus has been to try to find the evidence. Like, can we take these theoretical ideas that we got from Gibson and many other people and cash them out in an experimental context? And so trying to do that for optic flow began with trying to say, okay, Gibson says the focus of expansion in the optic flow pattern specifies our current direction of self-motion, right? Is that actually true? Like, do we actually use that information? First of all, can we see it, psychophysical judgments about it, but can we also then use it to control our behavior?
Yeah. No, I really like that. And I think one of the things I love about kind of the information, perspective control ideas is they make a lot of predictions about how we should move and what if I do this, very specific predictions we can test. So I agree with you. I said to someone the other day, why do you think there's so many papers on the outfielder problem? Like, people don't like baseball that much, right? It's just because it makes a lot of really testable predictions. It's also a good example, right, of I think you use this expression, how much of control can you get for free?
Yeah.
I've heard you, right? So part of the approach that I think you use in a lot of people is, how far can I push this before I have to resort to saying there's some higher level map or something? Can you talk a little bit about that?
Yeah, that's great. So I think what really differentiates an ecological approach from a more cognitive approach is, let's not assume knowledge. Let's not assume a model of the world. Let's not assume representations. How far can we get in explaining behavior without having to assume a lot of cognitive apparatus? And at some point, we may be forced, right, to say, okay, I've learned something about the spatial layout of my environment that I can recall, right, or that I can use from past experience. But now we might have a different way of understanding that, right? If we start by saying, what's the current information? What's the, for the tasks that the kind of biologically relevant tasks that I perform, what's the information, and how far can I get in understanding behavior without introducing all of these other assumptions?
Yeah. Being able to talk about how people turn direction and is one thing, but on the next kind of step I saw you took is talking about navigation. Can we describe the path people follow through a complicated environment without just based on low-level control? And I know, is this I know of expression, it's from one of your articles, but I think Gibson's behavior is regular without being regulated. I always I think that's what you were, you're trying to show, right?
That's one of my favorite lines from Gibson. It's definitely from Gibson. And what did he mean by that, right? So when we're talking about action, right, or behavior of any kind, we tend to posit some sort of central controller that is orchestrating that behavior. And so when Gibson says behavior is regular without being regulated, what he's getting at is that maybe we can understand behavior as a consequence of all the constraints in the environment and the information that's available and the task that the subject is doing or the animal is performing, without assuming that there has to be a central controller to impose all of that structure on the individual animal, right? And so this is this approach of trying to distribute that control over the entire environmental context, right? The perception, the kind of animal environment context and the information that's available, without centralizing it in the brain.
Right. And I know the task you used in your work with Brett Fagan is your Venn lab, your in navigation lab, is having virtual obstacles, and you had to get around to a goal and getting the behavior just from the kind of local control laws of, right?
That's right.
Being repelled by an obstacle and heading towards a goal. Yeah.
So this problem of route selection, right? It's like, okay, so I'm walking through the environment all the time. It's a dynamically changing environment, whether you're on a soccer field or whether you're walking down the street. So how do I select a route? And the way this is ordinarily done in robotics is through some kind of global path planning algorithm, where you assume you kind of give the robot a map of the layout of its entire environment, and the algorithm will evaluate possible routes and select an optimal route according to some criterion, like minimum distance or minimum cost. But now can we explain that route selection? Instead of that, can we explain it on the basis of the current information that's available to the organism or the agent as they're moving through that environment? And so that's what Brett and I tried to do in that steering dynamics model. We said, okay, given that I'm seeing the immediate obstacles and I'm seeing my immediate goal, can I explain how people arrive at a route without prior planning, without path planning in advance based on some global optimization technique? And so we did develop this, what I still think of as the best model of things like obstacle avoidance and steering. And we're still working on this problem. We're working on moving obstacles at the moment, which turned out to be a more complex problem than we thought. They involve not only changes in your heading direction in your steering, but also changes in speed. And so we're coming again. I have a grad student who's coming at that problem again to try to develop a control of both steering and speed, right, which will explain how we avoid moving obstacles like another player on the soccer field. Yeah. And how the routes are then emergent, right, rather than planned in advance.
Yeah. No, I think that I love that. I think that work really nicely demonstrates that quote from Gibson, exactly what we can. It looks like you came up with some high-level plan to get through all this, but it wasn't really. Another one I wanted to ask you about, and this, I think, I don't know how long ago this paper was, 5 or 6 years ago. The one you wrote with Zhao is the one you were comparing online versus model-based control. And I actually have a review paper of baseball batting where you'll see it lays right on top of your paper. But I think you really do a nice job of laying out the contrast between the two. And I see, there's this constant push to integrate these ideas. I see all the time, and I think you do a good job. Can you talk a little bit about what you're trying to do with that paper and kind of where you think those two things are?
Right. So it gets back to this same question of, is there a central controller, right, for everything, which is based on a model of the world in some sense. So one way this is talked about in control theory, right, is as model-based control. And so we kind of, that reappears everywhere in the perception, action, cognition literature, particularly now that we have Bayesian models, right? So everything is based on a Bayesian model of the environment. So, the idea would be that in order to catch a baseball, say, I have to have a model of the trajectory of the baseball and therefore how I'm going to run to get to a particular location, its landing point at a particular time. And so we're doing a lot of advanced planning based on some internal model of, say, the physics of the world in that case. And the alternative is what we call information-based control, where I'm just locking on to the information that's coming from the ball's trajectory at that moment, which is leading me by the nose to get to a particular place at a particular time to catch the ball, right? And this would be the famous, Chapman optical acceleration cancellation strategy is one version of that. So those are kind of the two, extreme opponent views. And again, taking this conservative ecological approach, it's like, how much can we do just based on the current information before we resort to having to have an entire model of Newtonian physics in our heads? And we can go a long way, but there are these problems of, say, anticipation, right? Or when my view of the ball gets cut off, right? Can I somehow interpolate the trajectory? How am I dealing with these situations when there isn't enough information available?
This is a point you made that took me a long time to get, is that when you use perspective control, online control, you can go through periods without information because you're moving towards the current future, right? You're not but using information based on what's happening right now. As long as you keep the control of this pattern the same, you would get, and nothing else changes with the ball, right? You would get there.
Yeah. So, and I think this, these ideas come from David Lee and Reinhard Botz more recently, where, there is this idea of perspective information. So people, traditionally people think of, if I'm using the current information, I'm reactive, right? But no, information is prospective. It tells you about what's going to happen in the future, all current other things being equal. So there is information about what's going to happen in the future. So you're not just reacting to the present state. And that the time to contact variable is David Lee's famous example of this. So, the tau variable tells you about the time at which the ball will arrive in the future if current conditions hold. And that's what Reinhardt called the current future. Right? But there's other kinds of perspective information as well. And there's some interesting work that has been done in the last decade by Turvey and his students on how you can basically synchronize to a complex pattern of dynamic change without having to have an internal model of that dynamic system in your head, right? It's a kind of anticipation, right, that just involves you synchronizing with the complex dynamics of this other system.
Using the information online.
Yeah, but it's more that you're synchronizing your dynamics. Turvey and his students are talking about ways in which you can appear to be anticipating the behavior by virtue of synchronizing the dynamics to the dynamics of this external system.
Yeah.
And this can also be synchronizing to the kind of fractal dynamics of the system as well. So you match the fractality of the change that's happening over time in a way that anticipates what's happening at different time scales.
I'll have to look that up. I haven't seen that one. That sounds really interesting. And one idea I hear is, well, why don't I just have a predictive model that updates really frequently? And I think I know you guys talked about that in the paper. What is kind of your thoughts on that?
Yeah. So I think in the limit, so if you could say, okay, I'm always got an internal model of the world in my head. And whenever I have some input, I'm just going to update the state of my model. And so if you have continuous information, that view claims, well, I'm just continuously updating my model, right? The same thing is going on. I'm still using my model to control. And that seems to me to be a supremely unparsimonious theory.
Yes.
Now I've got to have this constantly running full simulation of whatever's going on in my environment. And I just don't believe that we devote our cognitive capacities in that way.
Yeah.
So it's much more parsimonious to just be running off the current information that's coming in. And when that information gets interrupted, right, you just kind of keep doing what you're doing until you get the next input, the next sample of information.
Yeah.
Or you use that prospective information that says what's going to happen, okay, and you're using that. And in the in the worst case, you're using some sort of heuristic where it's a rough approximation to what's going to happen, but you know that you will get another sample of information. Under normal conditions, that information is constantly available to you.
Yeah.
And so it's not like you're ever drifting that far off of the path of successful action.
Yeah. And it's back to the point we were talking about before, you can get so much for free. Why would you need to infer if adding all this when you don't need it? And so it's the same kind of how far can we push it? The other thing I really like about that paper, you talk about, there's this ultimate information-based control, but there's also kind of these subsets. I think you identify this, like I think you call them visual motor mapping, and the one you just mentioned, heuristic. Can you talk a little bit about that? Those, because I think they get a little bit into the issues of using, to me, non-specifying information sources. Can you talk a little bit about those?
Yeah. So and I think the partially this gets to the question of how would you really test that you have an internal model of the physical world, right? And what that model should do for you, it should be able to generalize to all kinds of new situations, right? And so that's the way to test whether you've really got an internal model. If you have something like a very task-specific mapping, it's not going to generalize outside a context of the task in which you've learned it. And so the example I use is kind of you're playing catch with somebody, but the lights go out, right, in the middle of the throw. And so that doesn't completely destroy your behavior. You're going to be worse, right, at catching the ball, but you're not completely wrong. And so, maybe what you're learning in these contexts is a simple mapping between the initial visible portion of the ball's trajectory, right, and how you should move your hand in order to get it to approximately the right place. Now, that's not fully specific information because there isn't really enough information in the initial part of the trajectory. But if the way your friend is throwing the ball is constrained, there might be enough to get you close enough to kind of satisfice, right, to get to the ball close enough so that you can catch it.
Yeah, no, I really like that idea. And the other way you can is if you constrain the conditions really restrictive, like hitting off a pitching machine when the speed's always the same, you don't need tau anymore, right? You just swing when the ball is a certain size. You've kind of created this mapping between size and time. That you're right. The key point is it's not going to hold generally is if you get outside this little range of conditions. But again, you're right. I think human beings are kind of lazy learners in a way, right? We'll latch on to these simple strategies.
But I think that's an important point, Rob, because in my mind, what makes Gibson's theory ecological is the observation that we're always operating within a limited context, right? We're never general Newtonian actors, right? We're always operating in a gravitational field with certain kinds of objects, with certain kinds of surfaces. And the information that makes information available, right? The constraints of that context make certain variables informative that they might not be in a more general context. And that's what makes the theory ecological, right? We're always limited. The information is defined within an ecological context.
Yeah, I think that kind of flips the traditional kind of impoverished view. You know, we only have view for a certain angle, so we can't accurately represent the object. Well, Gibson's point would be you don't need to, right? That's not what you need to do to control your action. I know the work you're doing now, you kind of expanded into kind of still kind of navigation, but now you've done some kind of issues with crowds, the way that people move in crowds and disperse in crowds, and getting into, if I remember, some engineering issues of, forces and things. Can you talk a little bit about that?
Yeah, so I think of this as just an extension of the problem of visually guided locomotion. So if I'm walking around the world, I'm avoiding obstacles. I might be walking together with my friend. I might be walking in a crowd to the train platform in the train station. And so I'm still using visual information to control my locomotion. And if other people are using a similar kind of information to control their locomotion, we're going to end up with collective behavior, right? And so to me, the problem of kind of crowd behavior is just a particular example of this general problem of collective behavior, which kind of occurs on all different scales, right? So, when I perform an action, there's collective behavior occurring among the joints and muscles of my body, right? And so we're looking at collective behavior in a way that may be more easy to study because it's kind of exploded out into space, and we can do experiments and manipulate it. So that's what led me to be interested in this problem of collective motion in crowds. There are a lot of models of this for bird flocks and fish schools. Many of them come out of physics, and we're kind of generalizing our basic model of steering dynamics to following dynamics, and ultimately just recently now getting at the visual information that's being used to control, to kind of walk together with a group of other people.
And linking that back to affordances, could that get into kind of some design issues? If the way you design things, if you're giving certain affordances and you're going to create this kind of collective bottleneck or whatever, the way that you design things, is that some of the kind of things you're looking at?
Yeah. So there's a whole set of work on what are called pedestrian models in evacuation behavior, right? So this is called evacuation dynamics. There are, again, different kinds of models of this, but how do you get everybody out of a burning building, right? And those are real practical issues. And so we've actually been thinking about this in terms of what we know about collective motion, collective behavior in crowds, and the affordances of, say, exits in a building. And so people perceive the affordances of their surroundings, right? In this case, of how to get out of a building, and that's going to interact with this tendency to move together with your neighbors. And it can either create catastrophes or it can create smooth evacuations.
No, I think that's really interesting work. And it's nice you can see the flow through your kind of connection of your work. It's really nice to see. I guess the last general question I wanted to ask you, Bill, is about your thoughts kind of about where we are with ecological psychology and ecological approach now. Where do you think where it is and where it's going?
Yeah, I mean, I think, there are many, many currents out there in the field of perception, action, cognition. Obviously, the kind of Bayesian statistical approach is kind of in the ascendancy right now. But I think in the ecological framework, there's also a lot of interest. And as you point out in athletic training, that's stimulated a lot of interest in those kind of ecological dynamics approaches. I mean, I think, they're kind of general problems and more specific problems. So I still think the problem of what's the information is critical, right? So we talk about information a lot, but as researchers, we have to really nail down, okay, what are the variables that are getting used in these contexts in order to effectively control the behavior. Another domain that I think is important is how do we put affordances and dynamics together, right? So if I think about, I don't know, walking out a doorway, right? I can treat that as an affordance problem. The width of the doorway affords passage for my own body. But we've also modeled it as a steering dynamics problem, right? So the door is an attractor of my heading, and so I get out the door. So how do I put these two things together in the same theory? And I think that's a really interesting avenue that we need to figure out.
Yeah.
There's also been a lot of work recently in what is kind of called ecological neuroscience. There was a special issue of the journal Ecological Psychology recently and some symposia on this. So I think people are kind of revisiting these old issues with new pairs of eyes. When you have concepts like dynamical systems or multifractality, and you kind of now or coupled oscillator networks. Let's kind of go back and revisit how we might think about neuroscience as the causal support for some of the perception and action problems that we are trying to study. Yeah. So I just in my lab meeting had a visitor come in to talk who said, there's been a dynamical turn in neural networks and machine learning in the last 5 years. And now they're modeling, right? Using coupled oscillator models to model convolutional neural networks, right? And you exploit the dynamics of coupled oscillators. So there's some, there are interesting changes going on that I think we are actively participating in.
Yeah, no, I think that's a really important thing. I think kind of a misunderstanding, maybe somewhat warranted, about ecological psychology is the pushing aside of the brain, right? Not thinking about what the brain is doing at all. So you mentioned, we talked a bit about the crowd work. Is that kind of what your next plans research-wise, expanding on that?
Yeah, so we've started publishing papers on that work, and we're currently looking at we've collected some crowd data and are doing network reconstruction on that crowd data so we can analyze who is influenced by who in a crowd. And that might allow us, using some theories of networks, to figure out, okay, if I wanted to, steer a crowd around in a particular way, where should I locate my tour guides, right? Or that sort of thing. So we're kind of interested in this problem of both perception and control.
Yeah, no, like I was saying earlier, I think you do a great job of marrying the problems of the theory with some real world interesting questions. So I think there's another great example. So thanks a lot for this, Bill. It was a really enjoyable discussion.
Appreciate it, Rob, and carry on with your podcast. It's really good.
Thank you. Thanks again for the great discussion, Bill. For those that were wondering, the anticipation work by Michael Turvey Bill mentioned is referred to as strong anticipation. Remember, you can contact me at robgray@asu.edu or follow me on Twitter at ShakyWeights. To find out more about the podcast, please check out perceptionaction.com. Finally, to support the podcast and receive bonus materials, including written transcripts, please head over to patreon.com/perceptionaction. This is Rob Gray from ASU. Cheers for now, and keep 'em coupled.